Hi everyone, welcome back to the channel. In today's video, I am going to show you the amazing product I built, an AI chatbot powered by a Google Gemini, LangGraph and Streamlit. In this chatbot can remember the conversations, messages, multiple threads, load past chats and give fast intelligent answers just like ChatGPT. Let's jump right into how this project works and what this project does. This project is a complete AI chatbot system that includes a backend AI engine using Google Gemini and a conversation graph created using LangGraph and a memory system that shares the load chats and a beautiful chat UI made using Streamlit. Supports for multiple conversations just like WhatsApp threads. A real-time streaming responses from the model so user can start a new conversation, switch between old chats and talk to the bot with full context. In this project we are using AI. So AI, how this works? So AI, the brain of the chatbot, is built using LangGraph, which is a framework for creating AI workflows. In our project we create a simple graph. So the graph start with first node is start and second node is a processing message with AI and last node is end. We give the model the user last message, Gemini generates a reply and LangGraph stores it inside the memory. So this makes the bot capable of remembering the past messages and continuing a proper conversation. And also in this project we are using Gemini API. So to keep things secure, the project loads the Google API key from the .env file in this project, the key, and avoids writing directly inside the code. The Gemini model we use is Gemini 2.5 Flash, which is super fast and perfect for the chat applications. And in this project has one of the coolest part of this project is multi-thread chat system. Every conversation get a unique ID, so user can start a new chat, switch to old chats, load previous conversation history, continue talking with full memory. This is exactly how ChatGPT or Gemini handles multiple conversations. In this project has another coolest thing, streaming AI response. Instead of waiting for full answers, the bot streams the message in a small chunks. This gives the user visible typing like experience a much better feel compared to showing the full response at once. Now we are going with backend file. From starting it is imported libraries. First one, this imports the core LangGraph structure. Import state graph allows building an API workflow, start and end, starting the endpoints of the graph. The next one loads environment variables from env files, help us reach to API key safely. The next one uses to define the custom data types from a workflow. And the next one, the keeps stack the messages and checkpoints for conversation memory. And also from LangGraph messages import base messages and add messages object representing the AI responses. And the next one, libraries to use the Gemini model. OS is used to read environment variables. The load.env is used to loads env files, so API keys become available. Here the generative API Google API key from .env, the configures the Gemini model for usage. Here we can create the API model. You can choose the Gemini 2.5 Flash model. The next one is creating a LLM model instances. This creates an object that can generate AI text. Here we can defining message state structure. This creates a dictionary that stores all messages in a conversion, annotated so new message can be appended automatically. And the next we can create a chatLLM node. This function is the brain of the chatbot. So in this loop goes through all messages, finds the last human messages and save the message text in the query. So we can write in this loop to save the first node of the LangGraph. After the next node we can create the response from the LLM to generate the content of the query. So this sends the user message to Gemini and gets the AI response. After the response from the generative AI or API keys, This returns a answer to the new messages that have to run. We have to return a messages contains to respond.text. And next we have to build the workflow of the graph. So we can use the checkpointer as a memory saver. So create a memory to store the previous messages, and that memory has to store in the graph of the state graph message state that defines the entire conversation graph using that message format. And after that we have to add a AI node, your chatbot brain, to the workflow of the LLM. That LLM defines the flow of the work, so from the starting to end of the nodes. So we can add the AI node to your chatbot brain to the workflow, and after that defines the flow. We have to create a graph that start node and middle of the chat LLM to the last one is end of the group. So compile everything into a running LangGraph workflow. So this is the workflow of the backend file. Here we can create a start and end node, and middle of the we are connecting to the API keys to the LLM. It is generative 2.5 flash. So generative Gemini API. So it is connect to the API key what we are giving to the message to the starting node or user. It is run through the messages back of LLM and gives the answer. So user can get this now. Now I am going with front end part, that is this builds a full Streamlit UI on top of your backend file. First one going with imported libraries. You also know from the backend pages of LangGraph messages import the base messages, and this helps to identify the messages types and imports the workflow of you made in the first file. And the remainings of the loads even new files and import the Streamlit is the UI. In Streamlit we can use the Swagger UI phases, and UUID gives unique conversations of ID, and OS used to environment variables. After that we can load the env files. So and the next we can generate the unique thread ID. It means we have to give the ID to the chat messages part, so it creates the random ID for each conversations. After creating the conversations ID, the next part to this add thread methods. It can add a thread to the section memory, and these thread methods to keep the track of all conversations user created. After adding the section memory to the thread ID, next we can create the reset chat button, so it can reset the new chat. So used when the user start a new chat. In this method we have the def reset chat and giving the new ID to the generate thread ID, and section state the thread ID equal to new ID. So after that we can add a thread to the new ID. So when we can execute the section ID states to the message on the history. After the reset we can going to create the load conversation from the backend memory. So we can use this def load conversation method. So within the write in the code of try and exception, because of the try exception we give the HTTP exception. So this method this retrieves the previous conversation messages from the LangGraph memory. After LangGraph memory we can going to extract the plain text from the AI content, because we are giving the user to the chat of the to the ChatGPT. So we can going to chat in the chatting section. So we have to extract the plain text to the AI content. So we can use this method, definition of extracting text from the content. So we can have to give the instances of the content, and the first one is the string, and second one we have to give the list. So join get a text from the API link. So this make the sure message content is clean text without giving any the proper symbols. After the message content is clean text file, we can going to create the initialization of Streamlit section state. So if message history not in the Streamlit section state, so Streamlit section state message history. So this stores the message for a display on screen. After this if statement, each section gets in own thread ID, and the next if statement is a list of all past chats. The next we can going to create the back buttons and reset buttons. So here this if statement, sidebar button, new chat and reset chat, can create the button to the reset chat. The next one to the sidebar header is title in sidebar. After the title in the sidebar, this next for loop is going to show all the odd conversations, then builds the message history, so you can continue to chatting, or we can going to take the next chat that gives the new ID. Next we have to show the message history, what we are the user who previous chatting history. So we have to display user assistant messages in a proper UI bubbles one by one. What is the previous thread ID, we have to assign the API keys to the user. We can, so user can checks the history after we done. After we are going to the user input AI streaming responses. So in this line user inputs and Streamlit.chat input ask something, so user want to, we can go into the chat, creating the chat box, so user gets the input from the chat box. And when user sends a messages with in this code we have to create the st.chat messages user have to create the message, so st.write user inputs. So when we write this code to user, display the user messages. After that it stores the messages from the section state of messages history and append to the role and user to the content. It is the annotated list of the messages where we are storing. Then finally we are going to create the configure of workflow. So what is this workflow is runs in the LLM. So LangGraph, so LangGraph tells the which conversation ID to use and which checkpoints to the load. Because of the we are assigning to the UUID to the chat record. So Stream AI response can give the receives the Gemini responses chunk by chunk. So in this method we can create the stream response from the backend API keys. So for messages meta in the workflow.stream, so messages can be section state, messages history made from messages. After that displaying stream AI messages shows the streaming effect like ChatGPT. So in this method we can go into final text st.write stream. So finally we have to save the final AI messages, so that messages are saved for display and memory of future conversation loading. And this is the front end code explanation. So we have to write these all functions to the run the Streamlit. Streamlit is automatically run in the web page where we are running. After that we have to run the front end page. And now we are going to run this program by using the Streamlit command, Streamlit run, and give the name of your file .py. And that is the complete overview of my AI chat project. We used Google Gemini, LangGraph and Streamlit to build a fast, intelligent chatbot with the conversation memory. Alright everyone, that brings us to the end of this video. Today you saw the how build complete AI chatbot using Google Gemini, LangGraph and Streamlit. From understanding the backend workflow to designing the agentic graph to create the fully interactive chat interface with streaming responses and memory. This tutorial helped you understand how modern AI system work. Make sure to hit that like button and subscribe. It really motivates to create the more deep practical content like this. And if you like to see advanced features such as RAG tool, calling, multi-agent workflow or deployment to the cloud, let me know the comments and I will create the full series. Thank you for watching. Keep learning and keep building, and I will see you in the next video.